my mountain. Does the height of that mountain, what's wrong? Sorry, this is like the height of it. So it'll be, I'll add through all the rest of it in a second. Sorry. Or a ramp. Is that better for you? Let's say I have a mountain slash ramp that's 1.5 kilometers tall. Does the height of that mountain or ramp necessarily or directly affect the speed, the average speed of a ball that would roll down? What would affect the speed of the ball? The average. Good. So this mountain here would give us, talk about average speed as opposed to final speed, because of course they all have the same final speed because of the conservation of energy. But if we were to time it, this mountain would take less time. If we draw a similarly high mountain, to draw it like this, that one's going to take substantially longer, correct? So the fact that this mountain was 1.5 kilometers tall did not affect the speed, the average speed of the time for the ball to go down. Would you agree? Yeah. So let's look at our example of that. Here is a little track. That's what someone in the room said. I'm going to see if I agree with that. Or the path down the mountain. Yeah. So here we have 4 tracks equal in height. Agreed? So they all are different slopes, so to speak, on the track itself, correct? Woo. So if the ball takes different times to get down, we would agree it has different average speed, correct? The big steel one?
Yeah, it's better.
Are you serious? I suppose there's 2 over there.
I don't know.
Yeah, that'd be really helpful, actually. Anyone else see a steel marble on the floor?
That one was underneath that stool.
The Dominic stole it.
I definitely didn't feel it.
All right, let's be a lot less impressive with 1 marble, but we can make do. I think.
There is a box, right?
Where?
There's a box now.
Oh.
I was playing with them yesterday. Yes, we
It all comes together. How affected Dominic causing trouble somehow? First, the marbles under the stool, then the box of marbles.
Alright, I didn't put them over there.
Okay, so here are 4 tracks here. We'll call them 1, 2, 3, 4. So if they're facing you, it's 1, 2, 3, 4 as we get closer to me. Which of these 4 do we think might be will result in the least amount of time to get down or the highest average speed?
The left one. By your right hand.
Track 1. That's my number down. Track 1, correct?
I didn't even tell me that.
My lord. All right, so we're going to test out the first 2 tracks. We'll see which one gets down the quickest. So the track number 1 was the quickest. Let's try this 1 versus 3. So still track 1 was the fastest. 1. And now 1 versus 4. And still 1 is the fastest. And so the point I'm trying to make here is that the height of this did not control the average speed. Much like the point I'm going to make today, I'll give you a preview, that the battery did not control the speed in the circuit. The slope of this hill controls the speed of the marble, much like something else in the circuit will control the speed of the circuit. Okay? The slope of this hill controls the speed. So let's ask you now, before we get to the other point here, what does the slope, in circuit terms, what does the slope of this ramp correlate to, if I'm making my analogy? The slope. What? The resistance. Resistance, very good. The height is the same, would be analogous to the potential difference. The speed of the marble would be analogous to the current, and the slope of this guy would be equivalent to the resistance. And so the steeper the slope, there's less resistance, and it's going to go faster. And that's what they kind of board them on. I'm going to say it again in a minute, don't worry. I'm going to try and say it a couple times. So, the height of this hill doesn't affect the speed directly, much like in a circuit, the voltage of the battery isn't going to necessarily affect the speed. Now, if this hill were higher, would the marble go faster? In general. Now, a taller mountain will go faster marble. Much like stronger battery would result in faster charges, but that's like an indirect relationship. That's because from our I equals V over R equation. So the height of this mountain I'm going to claim is equivalent to the change in potential you would find in a battery. The speed of the ball we roll down the marble is going to be equivalent to what? Current. So the speed of the ball would be the equivalent to the speed of the electron. And then the slope of this hill, as Alex points out, would be equivalent to the resistance. Slope equals R. Slope equals resistance. So, can two objects travel down the same hill with different speeds? Yes, clearly. I mean, clearly that's the point we're making here. So, two electrons could leave the same battery and travel on the circuit with different speeds if they wanted to. Read what's wrong? Speed equals I. There you go.
No. Next to the R. On the right hand.
This is a marble.
Oh, it is.
Sorry, I should.
No, that's all right.
I'm still learning how to use this stuff. They go at different speeds. The marbles, these marbles here, why are the currents different? So there's different levels of resistance in a circuit. So if you have one circuit with like 5 light bulbs, or with 1 light bulb, if they have to go through 5 light bulbs, it's going to go slow. No, I'm sorry. The same battery in different circuits could produce different speeds. So maybe if you missed her, if I said it wrong before, I'm going to ask how you see what I said to her. I meant to say was the same battery in different circuits could produce different currents. And you'll see in one circuit it's called the same current. Yes. So let me talk about one more thing here, and then we're going to go back to the actual question 13. So let's talk about a mountain again. This time we're going to actually be on physically the same mountain. We're going to use Here's my mountain. Oh. Mountain might be 50 meters tall. No, there is going to be 2 paths down this mountain. There's going to be one path right here. Another path that's going to go like this. It's going to be a kind of path. Like that. Which of those paths, if you were to roll a ball down this mountain, either there or there, on which of those paths would the ball change in height be bigger?
Would they be the same?
Absolutely. The change in height would be equal. Yay. And which of those 2 hills would the change in potential energy from gravity be bigger? It would be the same. The change in gravitational energy would be equal. Check. Because remember, Eg is just m times g times h, and the marbles are the same mg, same change in height, giving the same change in Eg. Agreed? But would they do that in different times? So again, same idea. You have a certain mountain or a certain battery that produces a different energies, but based upon the path, that will control the speed. The point I'm trying to make to you again is that the battery controls the height of the mountain, or how much different the energy is going to be. The path is what's really going to control the speed. Okay, if there's more or less resistance or more or less stuff to go through, that's going to control the speed. If your road with no speed bumps or with a speed bump, that's a different how fast you go. The time or average speed is different. This marble is going to take longer to get down, and so it's going to be a higher average speed. Okay. So, questions about any of that? Anyone disagree with those statements? Because when I go back to the battery, some of you are going to try and argue with me. So remember, you all agree with these statements.